Hello students and welcome to yet another video on Foundation course for Business Statistics. In this video, we are going to look at some of the observations that are noted on standard deviation. In the last video, we have seen what standard deviation is, and in fact, we have uh, explored the formula of standard deviation, which is given here, and we have also solved one of the examples, right? So I'm not going to go through the details of the formula for standard deviation. If you haven't seen, my request is to go and see the last video on standard deviation. So let's see what are the observations that are noted on standard deviation. Standard deviation is always computed from arithmetic mean and is always positive. So very important. Standard deviation is always positive. Standard deviation is never negative. So when you take a square root, it is the positive square root is what you are taking. Okay, so standard deviation is not negative, it is positive. Smaller the value of standard deviation or variance, you know what variance is. We have seen in last video. Standard deviation square of standard deviation gives variance, right? So smaller the value of standard deviation or variance or coefficient of variation, uh, the more uniform or the more consistent the distribution is. In other words, the observations are clustered around the mean. They are close to the mean. If the observations are if the observations are away from the mean, if the variation is high between the observations and the mean, then standard deviation is going to be high. Standard deviation and variance is independent of change of origin, but it depends upon the scale. So what does it really means? Okay, suppose you add. Okay, suppose you add, or let's take an example. You have observations x1, x2, x3, and x4. If these are the observations, right, and standard deviation is, say, uh, example z, right? So this is the standard deviation. Now, if you add k quantity to each observation, I repeat, if you add k quantity to each observation, right, x4 plus k, then the standard deviation for this new series will also be z. It will not change. That is what it means. Okay, when we say that it is independent of the change of origin, which means if I add k, okay, or subtract k, I can also subtract k, x1 minus k, x2 minus k, or x3 minus k. If I subtract k from each observation, or x4 minus k, then my standard deviation is not going to change. It is going to be same. Okay, whereas if I multiply the observation, if I multiply each observation, kx1, kx2, kx3, and kx4, if I multiply each observation with some value k, in that case my standard deviation increases, or it gets multiplied by k. So it is kz, right? So this is what it means. On the next slide, let us quickly see the example of this. So let's change of origin. Let's see what example is. If we add 10 to every data point in a data set, that is, shift the data, the mean will change, but standard deviation stays the same. So my data, every observation gets shifted. If I add 10, it will get shifted by 10. So obviously my mean for that new data set, right, will change, but the SD, standard deviation, remains the same. Okay, so standard deviation does not change when you shift all the values up or down. When you say up, which means you add, when you say down, you subtract some value. And here is a quick example. Original data is 2, 4, 6. Obviously, my mean is 4. If you want to find, it is 2 plus 4, 6 plus 6, 12 divided by 3. This is 4, and my standard deviation is 2. Now if I add 10 to each of these values, so my new data set will be 12, 14, 16. Now look, the mean will change. Now the new mean is 14, whereas my SD still remains to be 2. So my SD has not changed. And that is reason why we are saying SD is independent of change of origin. And the values can go either up or they can go down. What's change of scale? This means multiplying or dividing all the values by constant. Standard deviation does change proportionally when you change the scale. Example, now my original data is 2, 4, 6, and standard deviation is 2. I'm multiplying each element by 3. So my new data set is 6, 12, 18. In this case, my standard deviation has become 6, which is nothing but 3 multiplied by 2, because my original SD was 2. Now since I have multiplied each element by 3, right, my standard deviation has also increased by multiple of 3. So 3 times the original standard deviation, right? So SD depends on the scale, right? So this was the short video in which we saw few observations on standard deviation, that it is always positive. Uh, it doesn't change if we add some constant, or from all the observations, or if we reduce some constant from all the observation, whereas it will change if we multiply or divide all the observations with the constant by the same factor. Okay, so that's what we have seen. uh, so we come to the end of this video. In next video we will see few more numerical examples of standard deviation. uh, Thank you so much, and bye till then.